So far we have understood the algorithm behind linear searching algorithm, right? And linear searching algorithm seriously does not care if the values are sorted in ascending order or in descending order, or if the values are arranged randomly. So what it technically will do, it will go to each and every index in the array and it will try to read the value at that particular index, and it will try to compare the value at that particular index with the value that user has passed. If it matches, it will return the index at which that value is available. But what if we are asked to search for a value in a sorted array, right? Even in that case also, we are going, the time complexity will be order of n only. But if you apply a little technique, we can bring down the time complexity from order of n to order of log n drastically. We can basically bring it down. That searching technique is nothing but binary searching technique. So in this video, let's try to understand everything that is there with respect to binary searching algorithm. So in binary searching algorithm, what we exactly do is we will try to search in only half of the array by taking the help of mid, a variable called mid. So what we do in the beginning is we will try to calculate the middle index in the array. Okay, so based on this middle index, if the value at this middle index is equal to the value that user has passed, then we will return the middle index itself. But if the value that user has passed is not at the middle index, since the array is sorted, it could be either available on the left side or on the right side. So what we can do, we can eliminate searching in the remaining half of the array, right? And we can again calculate the middle index, and we can go ahead and search if the value is again available in the middle index in the remaining half of the array. So that is the logic behind binary searching algorithm. Let me explain the same thing with a small example so that you will have a better understanding. So let's assume that the array that we have given is arranged in the ascending order like you see on the screen, and it has these values, and the values are at the indexes 0, 1, 2, 3, 4, 5 and 6. So totally we have 7 values inside the array that we have been given. Now let's assume that the value that user wants to search is basically, let's say, minus 51. Okay, now as part of the binary searching algorithm, what we do, we will try to calculate the middle index. So here the middle index is basically the starting point is 0 and ending point is 6, right? Because the array starting index is 0 and ending index is 6. So mid will be 0 plus 6 by 2, which is nothing but third index. Now what we will do, we will go and check the value at the third index. At the index 3, we have the value 19. 19 is not the value that user has passed, right? So it could be either available in the left part of the array or on the right part of the array. The left and right part of the array is nothing but the array that is on left side of the middle index, and the right part of the array is nothing but which is on the right side of the middle index. So but how we will know if it is on either on left side or on right side? If you observe, right, here the array is sorted on the ascending order, and the value that we have been given is minus 51, but the value in the middle index that we calculated is 19. Since the array is sorted in the ascending order, right, obviously since the value at the middle index is 19, and all the values on the right will obviously be greater than 19. Okay, don't confuse here. Since the value we have in the middle index is 19, and since the array is sorted in the ascending order, all the values on the right are obviously greater than 19. So there is no technically possibility that the value minus 51 could be on the right side. So obviously it has to be on the left part of the array, right? In that case, what we will do is we need to search it in the indexes from 0 till middle index minus 1, that is till 2. So in that case, what we will do is we will update the end, we will move the end to index 2. Okay, now we will again calculate the middle. So the starting index is 0 and ending index is 2. So divided by 2, which is nothing but 1. So what we will do, we will go on to the index 1 now. index 1 has a value of -51, which is matching with the value that user wants to search. So what we will do, we will directly return index 1. Okay, this is how we actually implement the binary searching algorithm. So technically what we are doing, we are basically calculating the middle index in the array. If the value at the middle index is matching with the value that user has passed, we will directly return. Otherwise, since the array is sorted in ascending order, the value could be on the left side or the value could be on the right side. Based on that, we will move on the values. But let me give one more example here so that we will update the start index on the right side. Let's assume that the value that user wants to search is 76. In that case, we will start with 0 as start and end we will start as 6. In that case, we will calculate the middle, right? So in that case, middle equal to 0 plus 6 by 2, which is nothing but 3. And the index 3, we have a value of 19, which is not the value that we are looking for. The value that we are looking for is 76. So obviously the 76 is larger than 19, right? So it will be on the right part of the array. So for searching on the right part of the array, what we will do is we will update the start to middle plus 1. That is nothing but index 4 will be starting value. Now we will again calculate the middle. So middle will be 4 plus 6 divided by 2. 10 by 2, which is nothing but 5. Now what we will do, we will go to the index 5, which has a value of 57. Obviously 57 is not the value that we are looking for, and 76 is greater than the 57. So obviously what we will do, we will move on to the next. We will update the start to middle plus 1. So start will also move to the index 6. Now what we will do, we will again calculate the middle. So in that case, 6 plus 6 divided by 2, which is nothing but 12 by 2, which is nothing but 6. Now what we will do, we will go on to the index 6. At index 6, we have value 76, which is nothing but the value that we are looking for. So obviously we will return index 6 as a output. But some cases, let's say the value that user wants to search is 78 or something, which is greater than the largest value we have. In that case, what we will do here, middle, whatever the index 6 also, we couldn't find the value 78. So obviously we will upgrade the start to 6 plus 1, that is nothing but 7. Now here we are going beyond the largest value in the largest index in the array, so we don't have to perform searching anymore. That's how we will stop searching further into the process. Okay, that is something to remember. But one more thing is, here the array is sorted in ascending order. Okay, if the array is sorted in descending order, you will need to make the change of updating the start and end. You just need to exchange those two operations. How will that is, basically, let's assume that the values that we have given is 76, 72, let's say 70 and 65 and 64 are the values that we have been given, and here it is sorted in the descending order. And let's assume that the value that we are looking for is 72 and the indexes are 0, 1, 2, 3, 4. Now the middle will be, start will be at 0 and end will be at 4, and middle we will calculate with start plus end divided by 2, which is nothing but 2. At index 2 we have a value of 70. Okay, now the value we are looking for is 72. So since the array is sorted in descending order, the larger values will be on the left side. So we will update the end to middle index -1. Okay, again we will calculate the middle. Middle will be 0 plus 1 divided by 2, which is nothing but 0.5. Since it is a floating point number, we will floor it. So the middle will be 0. Now at index 0 we have 76, which is larger than value 72. So obviously the smaller values will be on the right side. So we will update the start to index, start to index 1. Again we will calculate middle. 1 plus 1 divided by 2, which is nothing but 1. At index 1 we have value 72, so we will directly return the index 1. Okay, you just need to swap the operations of updating start and end in the case of if the array is sorted in descending order. That is something that you have to remember. Okay, very simple algorithm. In each and every step we will calculate the middle index just by dividing start plus end divided by 2, and we will simply go on to search at that middle index. If we find that value at that middle index, we will simply return. If not, based on the way the array is sorted, we will either search on the left side or on the right side. Okay, that is the algorithm behind binary searching algorithm. Now that we have seen the algorithm behind binary search, let's try to write the pseudocode for it. Okay, so as part of this implementation, we will simply be writing a function called binary search. It will accept the array and the value that user wants to search. Inside this function, we basically take the help of 3 variables. One is the starting index and the ending index and the middle index, right? So for that, I will declare a variable called start and assign it with 0, and I will also declare it with variable end, and I will assign it with length of array minus 1 because that is the last index. Again, I will define one variable middle and I will assign it with minus 1. In the later I will calculate the middle and I will update it with that specific value. Now what we will do is we will run a loop as long as the start and end are not overlapped. That means that there are still some unprocessed elements or unchecked elements on the array. That means as long as start is less than or equal to end, what we will do, we will simply calculate the middle. Middle is nothing but start value plus end value divided by 2. Now what we will do, we will compare the values at the middle index. So if the value at the middle, that is array of mid, is if it is equal to the value that user has passed, then what we will do, we will simply return the index itself, that is return the mid itself. Otherwise, that means else if the value at that middle index is greater than the value that user has passed. That means since the array is sorted in ascending order, whatever the value we have in the mid is greater than the value we are searching. That means the value could be on the left side. So what we will simply do, we will simply update the end to mid minus 1. What if the value that we are searching is larger than the middle index? That is nothing but else. In that case, we will simply update the start equal to, because the value will be on the right side. So we will simply update the start to mid plus 1. Okay. And once we complete all this logic, right, and we have also overlapped start and end, that means that no other position in the array has the value that you are looking for. So in that case, we will simply return minus 1. Okay. This is the pseudocode for implementing the binary searching algorithm. So we are simply taking the help of 3 variables, start and end, which are basically defining the range in the array that we are searching. And as long as start is less than or equal to end, we are simply going on to the middle index and comparing the value, and we are simply searching and return. But this is in the case of the array if it is sorted in ascending order. But if it is sorted in descending order, right, all we have to do is we just have to swap these 2 lines of codes simply such that it will work perfectly fine. Okay, that is something to note in the implementation based on the way it is sorted. Okay, now that we have understood the algorithm and implementation behind binary searching algorithm, let's try to understand the time complexity and space complexity. Okay, in the time complexity and space complexity also, let's try to understand in the best case and in the worst case. Okay, when will the best case of the binary search will occur? Whenever the value that we are searching is available in the middle index, so that it can be found in the very first iteration itself. Let's say here the value that I'm searching for is 19. Okay, in that case, in the very first iteration itself, the middle index has the value 19. So in that case, I'm returning the index in a single iteration here itself. So in that case, whatever the while loop that we have written, right, this while loop will run only once. Okay, so in the best case scenario, obviously the while loop is running one, and all that statements we have before that are basically declaration and operations. Obviously they will take only constant amount of time, right? So as a result, in the best case, when we have the value that user is searching for exactly in the middle, so that it can be found in the very first iteration, in that case the time complexity is order of 1. Okay, in the worst case, what could happen, it could lead to find the value in the very last comparison. That means either the value is minus 71 or 76, or it could be larger than 76 or smaller than 71, which is not available in that array. So in that case, what exactly is happening, in each and every comparison we are eliminating the half of the array in the remaining array. So if I have to search, let's say minus 71, I am eliminating the right half of the array in the first iteration, and in the second iteration I am further eliminating the remaining half of the array, and in the end I am reaching the index 0, which has the value minus 71, or it could be any smaller value that is not there in the array. So technically speaking, if we run this while loop once, we are dividing the array into half. If say there are n number of values in the array, if we run the iteration once, we are dividing the array into n by 2 for one iteration. If we run the iteration for the second time also, it will be divided into further half, that is n by 4, which is nothing but n by 2 square. If we run the third time iteration, this n by 4 is further divided into half, that is nothing but n by 8, that is nothing but n by 2 power 3. Similarly, if we run this operation for k number of times, right, that means this will be n by 2 power k. Now what we will do is, ultimately it is becoming 1, right? In the end we are reaching to a point where the half of the array has only one value. So if we apply the mathematical comparison, n will be equal to 2 power k. If we apply the logarithmic operation, log n equal to log 2 power k. So log n divided by log 2 equal to k. Now k is nothing but log n base 2. Okay, this is the time complexity in the worst case, because in each and every comparison operations we are eliminating the half of the array and we are only searching in the remaining half. If it is not found, again we will calculate the middle and we are dividing it into further half based on the number of times of iterations that we are doing. This is the time complexity we got. So in the worst case, the time complexity is order of log n. Similarly, let's try to understand the space complexity. Be it in the best case or worst case, obviously we need to have all these three variables declared for sure. Okay, and in the while loop also we are only making reuse of the middle variable that we have already declared. That means whatever the memory that we have assigned for this mid variable, that itself we are reusing in the division operation. So obviously all these variables will take constant amount of time, and in the while loop also we are not declaring any additional variables. As a result, this while loop will also take constant amount of memory for execution. As a result, be it best case or worst case, the space complexity will still remain order of 1 in the case of binary search. Okay, that is how the binary search implementation will look like in terms of space and memory consumption. Okay.